So good afternoon, everyone. My name is Franck. I'm working in SINTEF Digital in Oslo, in Norway. And before my colleagues dive into the case study of the Arcadia project, I would like to talk about a work we have been doing about trying to align the Arcadia concept with the TOSCA standard, which is the most prevalent standard in cloud orchestration. So, although my colleague Lucas has already summarized the main things in the Arcadia project, so one aspect of the Arcadia project is actually the management of cloud application. So Arcadia is focused on infrastructure as a service, and so the challenge with the cloud application is basically to manage them, because they are made of many moving parts, which could be software components, resources provided by cloud providers. Those are complex entities which are ever-changing, and there is a lots of provider-specific things. So, for instance, something that works on Azure provided by the Microsoft, you will find something similar provided by Amazon, but it's not going to work exactly the same. So you have some vendor locking issues and other things like that. And so basically the management of this type of application is always difficult and error prone. And not only it's error prone, but errors made in a production environment can be very costly. And this has been already experienced by many companies. So there is an effort in the cloud community to try to automate as much as possible the management of cloud application. And one result of those efforts is the TOSCA standards, which is exactly about this, trying to automate the deployment and management of cloud applications. And so in this presentation, what I want to do is I want to explain a bit an effort we have been doing in the Arcadia project to try to align as much as possible the concept of Arcadia with some of the concepts of the TOSCA standards. So this is what I'm going to talk about in the next 10 slides. So Lucas has already introduced the Arcadia project, so I will go very quickly. So basically the research challenges are to develop efficient and reliable distributed application, and to try to help with the deployment of those applications, especially how you deploy the services according to some operational constraints. So actually what's interesting in this slide is that this fits very closely the description, the rationale behind the TOSCA standard. So I think in terms of intention, it's actually very close. So I'm not going any further in this, but so one important artifact in the Arcadia project is a context model, which is a data structure that tries to capture many different aspects of the software component and the resources we are going to get from the cloud. So it covers many aspects. I don't necessarily want to dive into the details here, but for instance, you describe some metadata about your software component. How do you configure them? How do you trigger some phases of their life cycle? For instance, how do you start them? How do you stop them? You will also describe how you combine those components into an application. So basically what we name in the Arcadia parlance the service graphs. So how do you change, for instance, software components in order to build an application? How those components are linked together? How do you monitor, for instance, the performance of a service graph? And another aspect, and there are other things in the context model, but those are the three ones I would like to highlight, is how do you deploy the things? Where do you put the software component on what virtual machine? For instance, is there any constraint between those virtual machines? Are you allowed to put all your components on the same virtual machine? Or there might be, things might be complicated. And so the context model is there basically to capture all the information you might have about how you are going to use those components. And those informations are basically consumed by the Arcadia smart controller that my colleague Lucas has previously introduced. And the smart controller is going to provision resources on the infrastructure as a service layer, and then deploy the component, monitor how they perform at runtime, and take decision to adjust. Could be the placement of component, it could be local configuration actions, which often are expressed in operational policies. So just to contrast this, so this was the Arcadia side of it. Now I want to go to the TOSCA side of it. So you may not know TOSCA. So TOSCA is, as far as I know, the only, I would say, operational standard in the cloud world. So it's actually a standard which is pushed by the OASIS organization. And TOSCA stands for Topology and Orchestration Specification for Cloud Applications. So this is discussed by more or less about 70 companies and more or less 150 persons. So there are many big companies behind this. I mean, from Google to Intel to many other. You have some logos there. I guess you recognize some of the logos. And so what TOSCA is about? So TOSCA is about the topology of cloud application, which is basically what are the software components running in the application, how those softwares are managed, so what is their life cycle, how do we start them, how do we stop them, how do we configure them, how do we connect them one another, and how do we deploy them. That's basically the main idea of the topologies in TOSCA. But TOSCA is not only about the topologies. Well, I'm sorry you can't see it in my slide, but here actually there are as well another gear which is the workflow. So TOSCA is also about how do you standardize management operation of our application. So for instance, if you have a process, I don't know, to back up your application, or to you have a failover mechanism in terms of failure, you suddenly switch to a replicate of your application. So this type of management workflow can be automated and described using the TOSCA standard. So for the workflow part, TOSCA actually rely on another standard, BPMN, and you should be able to use any kind of standard notation for workflow to express this type of management operation. And the last things that TOSCA is dealing with are actually policies. So you might have policies, for instance, that if the performance of one of your application is too low, you might want to switch to, for instance, as I said, another replicate of that same application. So this type of runtime policy can be captured in TOSCA and described using the TOSCA syntaxes. So what TOSCA gives you concretely, as opposed to Arcadia, TOSCA does not give you an orchestrator, but TOSCA gives you a way, a language, or a data structure to describe these things. So to describe the topology, to include a workflow that describes the main management operation you want to carry on your application, and also to describe the policies. So basically there's two syntax, an XML, a standard XML document, and a YAML format. And this is to be consumed by compliant orchestrator, either open source or potentially commercial solutions. So just to give a quick example of what you would describe in a TOSCA service templates of the name of topologies in TOSCA. So here it's about a WordPress application backed up by a MySQL database. So you would basically describe the WordPress application, which is hosted on a web server. In that case, it could be, for instance, Apache or Tomcat, whatever web server you would like to use. And this thing is also hosted on actually a compute node. So that could be, for instance, a virtual machine provided on Azure or on Amazon. And coming back to that WordPress component, which is running on the web server, this, of course, is connected to the database. And the database is hosted on a database management system. In that case, it could be, for instance, MySQL. You have one MySQL database running inside a MySQL server, which is also hosted. So in that very picture, I'm showing settings where the database is running on the same compute node, so on the same virtual machine, but I mean, TOSCA lets you describe the things as you would like them to be. So this is basically an example of TOSCA service templates. So why am I talking about service templates? It's because TOSCA, as far as I know now, is mainly concerned about describing the application and trying to automate the deployment. So once I get this description, I can trigger a TOSCA compliant orchestrator that will consume that description, provision all the compute nodes, deploy the web server and the database server on that compute node, and then install the component, configure the connection between the different endpoints there, so that the things are operational. There is not yet much in TOSCA about monitoring and managing runtime application. So that's why we talk about service template. This is a template that can be instantiated in many places so far. And the way it would looks like in TOSCA, I try to simplify a bit the figure, is that you would describe for each component, you see the properties, like here if we talk about the MySQL server, you need to know the root password, the port where the server is listening. You need to know, for instance, what are the management interfaces, so in that case it could be some scripts, and then you would go on like this. So this is a small example of the YAML syntax, and you will have to go on and describe all the components that were on the previous pages. So one thing important about TOSCA is not meant to be tightly coupled to any technology. It's meant to be technology independent. So you can basically refer to whatever script you have for your deployment, whether they are, for instance, chef recipes, or whether they are shell script or Python script that you are using to automate the things. And so the one thing that the TOSCA committee is working in which I'm personally involved is the creation of what's the name, the TOSCA instance model that would actually address this problem of monitoring the running application and being able to, from the information we have monitored, that could be performance metric, that could be runtime status, whether you have detect errors or in the logs or whatever, being able to make decisions and then trigger other management operations, for instance, to scale up, scale down, to migrate things if it's needed, to deploy a third failover things, whatever you have in mind. So the overall idea of the instance model is that a TOSCA compliant orchestrator, for instance, Cloudify or Apache Brooklyn, would actually monitor the running system on some cloud services. It could be Microsoft Azure or Amazon Web Services or OpenStack if you have an OpenStack installation in-house, and then build and expose actually a model of what's running on, like what are the instances, for instance, of the TOSCA service templates that are running. So it could tell you, well, on that machine with that very IP, I do have actually a MySQL server running and the status of the server, that everything's fine. And on that MySQL server, there is like 2-3 databases which are hosted there, and some databases are performing better than others, this type of thing, this type of runtime information. And I mean, if I step out from that picture, the main rationale behind this, behind exposing runtime information at runtime is that we want to enable reasoning on those information. And whether it is human-based reasoning, like someone looking at the data and say, wow, that database is overloaded, we need to do something about it. And so, or whether it's something fully automated. You see, we picked up in the log and we see, oh, there are many errors writing in the log for that database, so something has to be done, and then he computes what has to be done. And then what he would do is that he would change that description, that data structure into, from a description, this would become a prescription of what the system should be, and then the orchestrator should be able to compare the current state of the application and the needed state of the application and compute what changes have to be made on that application, and then make the changes as far as possible, or maybe inform the user that some changes cannot be performed because by some other means the system has changed faster than we thought. So this is the main rationale behind the instance model. You see, trying to enable full automation of the life cycle of a cloud application. So, so this is just a small example of very small part of the working draft specification of the instance model. So I've noted this as confidential because this is not yet a public document. So what you would find in that specification is actually a data structure. Here it's depicted as a UML class diagram, but that told you basically what things you can describe. So here on that small example, it's about an instance node. So node being any kind of things from a software component to a compute node. There is many normative type of nodes that you can use in TOSCA. And then what are the capabilities that are actually provided at the time this was made? What are the requirements? Who provide those requirements? What are the properties? So properties being what information come from the templates, what are the attributes, so there are the runtime information that do not come from the templates, but that are available at runtime. You see, and then of course, this model has to refer to many other documents. And so there will be, for instance, okay, this instance node, what template does it refer to? So the instance model is meant to be self-contained, so he has his own notion of references, and then you can refer either other TOSCA documents or other workflow documents or this type of things. I don't want to go any further in this, I don't want to dive into the details, but it's just to get a sense of what's in that specification. And so how would we align TOSCA and Arcadia? So actually Arcadia has three main concepts: the concept of components, service graph, and which are deployed basically on the Arcadia framework. So one idea is that if we are able to convert the Arcadia component into TOSCA types, that would give you things that we can combine in the TOSCA world, and then you can describe a TOSCA topology that would reuse those equivalents of types, and then we can convert a TOSCA topology into an Arcadia service template that then can be deployed by the Arcadia framework. And of course, at the end of the project, as I was saying, we hope that the experience we gain in building Arcadia and managing runtime information, we use it to influence the specification of the instance model. But as I said, this is under development. And so we've made a small tool support to help with this. So we've developed actually an extension of the Cloudify orchestrator. So the idea is that we can describe a TOSCA blueprint that refer to some Arcadia types which have already and manually been converted in the TOSCA world. And then the TOSCA orchestrator, in that case Cloudify, can consume this blueprint and use our plugin to invoke the Arcadia framework and make the things and deploy basically what the application you've described in your TOSCA blueprint on the Arcadia framework. So this is what we have been working on in the last month. So of course this is still a prototype, but we are still working on it. So I don't think I will go any further into the details. I want to summarize a bit the main things I've been saying. So what we are talking about here is that we have a research project which is producing cutting-edge technology, and on the other side we have a standard which is moving at a much slower pace. But still, I think there is a mapping between these type of things, and we are trying to keep the Arcadia project compatible or in line with the standards which are pushed by the industry. So still it's different. You see, what we build in Arcadia is actually an orchestrator, which means it's a tool that automates the management of cloud application. And what we have on the standard side is a language to describe application. Also, this language is encompassing more and more things, including, for instance, now things to describe runtime information. We have choices that have been made by the Arcadia project. For instance, it's massively rely on Docker container and on infrastructure as a service. So actually, TOSCA made slightly different choices. TOSCA is meant to be both technology independent and provider independent. You don't have to, once you made a blueprint in TOSCA, you should be able to reuse it actually, whether it's on Azure or whether it's on Amazon or whether it's an OpenStack. One important focus in the Arcadia project was basically to be able to capture the policies that reflect how you manage your application, what matters when the application is running. So this also exists in TOSCA. Also, the support is pretty limited so far. This is somehow left at the description, at the option of the orchestrator. And then in TOSCA, in Arcadia, we focus extensively on monitoring the application and taking decision about where the thing should be placed, what has to be changed at runtime, and this is somehow new in the TOSCA. This instance model is under development, and also TOSCA also address NFV's network function virtualization, which I have not talked about yet, but this is also now a new interest in the TOSCA community. They also have instance group working on this. But I'm not necessarily the most aware people of that thing. So those are the main things I wanted to convey to you today, so that this is the Arcadia project, basically the main ideas, and still we are able actually to align it with the TOSCA thing, so that if people are very familiar with TOSCA, we should be able to use TOSCA as an enabler to use Arcadia technologies. So I think that's all I have for this presentation. If you have any question, I would be glad to answer.